a little bit more about how a liquid turns into a gas. You've already watched the video on phase changes, so you've heard the basics about liquid turning into gas. This is going to be a little bit of that video combined with a few extra things going a little bit in depth. So make sure you've watched the other video, phase changes, first. Okay, so something I want to talk about is liquid, we all know, turning into a gas requires heat. Remember, you can't do this unless you pump heat inside. So that's important to remember. Liquid turning into a gas involves heat. Now, when liquid does turn into a gas, we use the words evaporation, also known as vaporization, producing vapors. Vapors is another name for gas. So what exactly is vaporization? Let's kind of talk about that first. Well, vaporization is when a liquid turns into a gas, as opposed to just gas, which is at room temperature. So there are many things that are gases at room temperature, such as oxygen. Those are more appropriately called gases, whereas a vapor has to start off as a liquid at room temperature and then involves heat to turn into a gas. That is vaporization. So they're very similar concepts. Okay, how about this? What is the difference between evaporating versus boiling? Okay, so they're very much connected, but at the same time they also have their own distinct definitions. So let's take a look at these two beakers here. And if you notice, in this beaker I have water and in this beaker I have water, but this beaker also has heat, and I notice more gas molecules, and this one has no heat and a couple gas molecules coming off the surface. In order for a liquid to boil, you have to reach what's called its boiling point. And a liquid's boiling point is when the molecules at the surface are able to gain enough kinetic energy to push into the atmosphere. The atmosphere has its own gas that's exerting a pressure down on the liquid. As soon as the liquid in the beaker, as soon as its molecules gain enough energy to push through and create enough vapor, which is called vapor pressure, you can have boiling. So boiling is something that requires a lot of heat. Now, you can have molecules leaving the surface and not have heat. In that case, it's just called evaporation, which I have put in this picture here as well. In this picture, it's just a beaker sitting out, and over time, sometimes the molecules can jostle into each other, can bump into each other. Remember, water molecules move around a little bit more than solid molecules. You see them moving around. Not a lot, as much as a gas, but a little bit. And eventually what can happen is these molecules can bump into each other and make their way up to the surface and escape as vapor. Now, this process is purely evaporation because we're not reaching a boiling point to get those molecules to leave the beaker. And I'm sure you've seen this on many occasions. If you've ever just left a cup on your nightstand, right? Your cup might be full of water, and then you come back many days later and you notice the cup has decreased in its level, right? There's a lot less water. Where did that water go? Well, remember, like we just said, water evaporates, liquids evaporate. And eventually, over time, more and more of those molecules can make their way out of the glass or the beaker. Okay. So, just another review is that the only way liquid can turn into a gas is if those intermolecular forces that we had talked previously in the other video are broken. So don't forget about that, those intermolecular forces. Now, we've been talking about water a lot, but truth be told, this happens in any liquid. So let's take a look at this liquid I have here, which is gasoline. Okay, so in this container here, I've got all of these gasoline molecules, right? Gasoline, seen here, this actually is octane, C8H18, a bunch of carbons linked together with hydrogens surrounding them. So I've got a bunch of C8H18 molecules in here, kind of look like caterpillars, and they're liquids, and so they're moving around. And again, if they're going to evaporate, you don't necessarily need heat. But remember, when you do add heat, they also can evaporate. So evaporation can happen in two ways. Adding heat source to evaporate them, or leaving them on their own to eventually bump into each other, gain enough kinetic energy, and leave the surface, right? And that starts to happen over and over again. So evaporation can be sped up by putting more heat and causing it to evaporate faster. Okay, so heat can cause, obviously, evaporation. Now, here's a big misconception. Here's a very big misconception. And that misconception is, when these molecules evaporate, turning into a gas, that they break apart. That is wrong, okay? When these molecules evaporate, they have to break an intermolecular force between the molecule to escape, okay? Now, what's not happening, the misconception is, some students think that in order for the molecule to evaporate, it has to break apart. That is not true. That is the misconception. Molecules don't break apart. They just break free from the rest of the bunch. That is also true in water. So let's bring back our water example just to make sure you remember that. Our water molecule, seen here, when it evaporates, it does not break an H off and an O off. This is a misconception. This is not what happens when water evaporates. What happens when water evaporates is, let's bring back a picture of that, is that molecules, right, here's my water. A water molecule detaches from another water molecule. Notice the entire structure stays intact, but it has left its bunch. So another way it's saying you've got a group of friends hanging out and somebody leaves the room. That's what's happening. It's not saying you've got a bunch of friends together and somebody's arm detaches and leaves the room. So the molecule stays intact, it just leaves its bunch. Now, because the molecule stays intact, this is considered a physical change. Physical change. When the liquid turns into a gas, it's a physical change, not a chemical. If it was chemical, then we'd be getting new stuff. Then stuff would be breaking off. But since everything is staying intact, the atoms haven't broken off, it's just a physical change. Okay? All right, so let's bring in another concept. Or let's make sure we actually write that down. When a liquid boils or evaporates to become a gas, the molecules don't come apart. Again, the only thing the molecules do need when they want to come apart is they can evaporate, even if the solution's not boiling. They just need to have enough kinetic energy to break free. So those were some concepts we learned in this video. That's the end of the video.